So first, do you guys have questions about? Um, Okay, first, do you guys have any questions about your quiz? You want me to go over a version of it?
Just like to clarify, so with the 7 pi, so it's 0 because it's the number.
That's right, it's a number, so that's why it's like 3, right? 3 is a number, so the derivative of 3 would just go to 0.
And then, so when you're doing the first step, like doing the parentheses, and then bringing like the x's down and like out of the thing, is it only a negative exponent when it was like in parentheses and like a square root at the bottom?
Yeah, let me just pull that. Okay, so with this one, say it again, ask your question again.
So the last, the 9 over 2. So is the exponent only negative when it comes out of like the square root?
Well, this, I'm doing 2 steps here. The first one is that, if I get it out of square root, it's actually 7 over 2, but it's in the denominator.
Okay, so it's only in the denominator.
Right, yeah, and I can't do power rule if, I can't do power rule unless the variable is up top. So this one is okay. This one, I just made it x to the 3/4 and I'm already here. But here, this is 9 over 2 x to the 7/2. I got it out of the radical, but that x is still in the wrong place. So I gotta bring it up to the numerator before I can do power rule.
Okay.
Because I can't do power rule with that x sitting there. It's just not gonna work out.
Okay. And then, okay, yeah, and then so for the 8 or 7, it's already in that state, so then you have to pull it out and make it negative.
Right, that x cubed doesn't have any radical causing any issues, but that x is in the wrong place, so it needs to be pushed up to the top.
Okay.
Yeah, the hardest part is getting everything set up and ready. Because once everything's set, then you're doing power rule for every term, and it's just the same process, right? Bring the exponent down, subtract 1 from the exponent. That's not as hard. Any questions with number 1? Are you guys okay?
By for 24/7 because of the exponent affect the denominator.
24/7.
Uh,
Oh, this one right here?
yeah. The when it's multiplied from 8 7.
Oh, so yeah, up here. So you bring that -3 down, that -3 multiplies with an 8. You're already asking why doesn't it affect the 7? The reason why is because when you bring that -3 down, it's really 8/7 times -3 over 1 x to the -4. It's just not showing that 1 there. So you multiply numerator with numerator, denominator with denominator. The versions are slightly different, but it's kind of like the same things, right? All right, what about, you guys okay with quotient rule? What about, I think number 3 kind of threw some students off, right? Yeah, I'll go through number 3. I know, I think I attached the key to, did I attach the key to your version?
Oh, yeah.
Okay, good. So, it may be, this may be a little different than yours, but it's the same thing here. First thing is, just go ahead and expand everything out. So if I have x minus 1 squared, I gotta full it out. Remember, exponent takes precedence over coefficients. So once you expand all that exponent out, the key thing here is that we want to go through quotient rule. It's not going to be as clean. So we want to just go ahead and just clean up the numerator as much as we can. And then split up into individual fractions. And we're still in the cleanup stage. So you go ahead and split up into individual fractions. And then get all the parentheses to go away, get all the radicals to go away. So are we good up to this step here? Okay. Now, we want to continue cleaning up because we know that the variable is in the wrong place.
I've already calculated.
Yeah. Thanks. Variable in the denominator is not going to be good for power rule, so we have to bring it up. And the way we bring it up is we can subtract exponents. X squared over x to the 3/2, same thing as x to 2 minus 3/2. So 2 minus 3/2, that's 4 over 2 minus 3 over 2, and that's 1 over 2. 1 minus 3/2 is negative 1/2. 1 over 2 minus 3 over 2 is negative 1. And then here, there's no x here, so this x just comes up as x to negative 3. Now, while I bring the x up, any denominator just stays there, doesn't move. Any denominator coefficient doesn't move. So that's the hard part. The hard part is getting to this part. After this, it's power rule for every term, and we should be good with that. Hard part is getting to this stage. And then bring the exponent down, subtract 1 from the exponent. Right, so everything up to this point is just algebra. There's no calculus. The only calculus step is from here to here when we do power rule. But the hard part is to get it all ready for power rule. That's the hard part. Okay, good. The first page. What about the second page? Because I thought that these were pretty similar to the review sheet. I mean, I asked all the things that I was going to ask from the review sheet. So increasing speed, decreasing velocity, right? Decreasing speed, you compare signs. Increasing velocity, you just look at acceleration. Average velocity, you just look at position. You do change the position over change of time. And then when the PR stops, you set velocity to 0, you solve for t, and then you create your velocity sign line. Now, when you do your sign line, it's not with position, it's with velocity. So you have to check your signs within your velocity sign line, and then positive would mean moving right, negative would mean moving left.
Basically, for that back page, if you do like one thing wrong, you're kind of screwed for the page. Because then it goes so like.
I mean, if you. Yes and no. I mean, yes, if you made a mistake with your derivative, then your answer is off. But I try to take note of that and not take off as many points if I realize that, you know, that you made a sign mistake and that's why you didn't make the correct justification. But if you are making the correct justification based off of what you gathered, sometimes, yeah, a lot of times if I, when I see that, I'm like, okay, you understand the concept, you just have bad data, but I think I still gave you credit for that.
Yeah,
though.
you did.
Yeah, so if you, but yeah, if you have any questions about, yeah, so I definitely take into account. Yeah, like I don't want it all to snowball down, especially if you understand the concept. So I'm looking to see if you understand the concept. I want to give you credit for that. Okay, so you're gonna see another particle motion that show up on the test, very similar to this. Maybe it's a little bit extended because it's going to include displacement and distance, but I'm going to go over a full particle motion one, if not today, then tomorrow. And it's also in your morning review, so want to make sure you. If you're good with this, then the only thing that is added to this that will be on the test will be displacement, total distance, and then maybe also average acceleration. So average acceleration is just change in velocity over change in time. Okay, so are we good with quiz, or any questions from you guys? So let me just flip through a couple of pages and then have you guys tell me, okay, whether you feel good about it or whether you want me to go over something similar to it. Okay, so in terms of new topic, there's chain rule, which we can do one of. So yeah, why don't we do a chain rule? So this is page 4, number 13. Okay, so you'll see a problem like this on the test. So let's go through page 4. Okay, so first, do you recognize the need for chain rule here? Okay, there's an outside inside portion, right? Anytime there's an outside parentheses and an inside messiness, you know this is too messy for you to handle with just one rule. You want to kind of split up into 2 rules here, or outside inside portion. So we know there's a need for chain rule. And what's the outside portion? And the inside portion is, yeah, whatever you see inside, right? So outside first. What's outside's derivative? To the first power, right? What goes in here? Yeah, the original, right? No changes. Times. Okay. Yeah, and then what do we have to do if we do derivative here? Well, what rule do we call it? Quotient rule. Yep, quotient rule. Yep. So let's build out our quotient rule here. We're on page 4 in the packet. Right. We're doing a chain rule problem here. Okay, so let's fill out this portion here. What's f prime? G function. Original, yeah. Minus f. G prime. All over G squared. Okay, so on the test, I'm going to ask you to clean this up a bit. But really, it's just try to get it all under one fraction. So again, do not touch the denominator. Once your denominator is set, that's it. Okay. Do not try to cancel it out. Do not try to fold it out. This is a good place for it to be. The only really major cleanup you have to do is to try to find a way to get this to clean up a bit. So let's distribute the 1 through, let's distribute the 2x negative through, negative 2x through, and clean that up a bit. All right. One guess. Yeah, we'll have to date on it.
Yeah, so yesterday I couldn't go to the meeting because I had a dentist appointment. Like, I was just wondering, like, if you have like the information.
Yeah, are you thinking you want to join? Okay, what grade are you?
I'm in 10th,
Okay, what math are you?
pre-cal.
Okay, so. I'll actually see that. So we need a moment. Okay, so are we good with the cleanup here that we've done? This is the partial cleanup. I can do a little bit more, right? This ends up being negative x squared minus 10x plus 2. And now I'm just trying to merge it all under one fraction. Okay, so here's my g prime equals. All right, so what goes in the numerator? Let's go from left to right here. The 2 is going to be up there, right? 2 x plus 5. And this portion, right? This is negative x squared minus 10x plus 2. And my denominator, I got x squared plus 2, x squared plus 2. Now, how many x squared plus 2s do you see here? There's 2 here, and there's 1 here, so therefore 3. All right, x squared plus 2 times x squared plus 2 squared. I add exponents, right? 1 plus 2 is 3. Okay, so this is how I want you to show me your answer here. Leave everything in factored form. No need to expand. And this is a good place to be for future problems if we're looking for anything more like x-intercepts, vertical asymptotes, or sorry, slope undefined, slope 0. This is a good place to be. We don't want to foil anything out. Okay. All right, how do you feel about chain rule for this one? Now, just for some, let's say this was a 4 instead for some reason. Okay, then when that 4 comes down, it becomes 4 parentheses cubed. And how is this 3 going to impact my answer here? There's obviously going to be a 3 here, but how would it impact this exponent here? How many x squared plus 2 are now in the problem? Well, yeah, it looks like it's still 3, right? But it's 5. Why is it 5?
There's 3 of them.
That's right. There's 3 of them on this one, and there's 2 of them here. Now, the issue that I see some students run into is that they see the 3 and they see that it's for the x plus 5, but they forget the 3 also means it's going to be exponent for the x squared plus 2. So they see this 1 and they see this 2 and they make it a 3 instead of saying, oh, wait, there's actually 3 of these here and there's 2 of them here. So 3 plus 2 is 5. Does that make sense? Yeah. For 14, when this comes down, this will become squared. And then, so there's 2 of them here, and there's going to be another 2 that's going to pop up from quotient rule. 2 plus 2 is 4. Yeah, so just be aware of that. This is an easy mistake to make because that 3 is so far away from this denominator. Okay, so you'll see one of these on the test. How do you feel about quotient rule for this?
Is it gonna be one with the extra exponent app? Like will it be one?
Yeah, something like this.
And then a 3, or just one exponent that you pull down and there's not another.
It'll be something like this, like a 4 or a 3. Yeah. I mean, it could be a higher exponent, but it's the same process, right? Okay. And obviously, if you see, this is the key on page 5 here. Obviously, if you see a square root with the messiness in it, you always want to rewrite it using parentheses. And once you see a parentheses with exponent outside, you know that's going to be chain rule. You know it's going to be outside inside portion, right? So just being able to rewrite a problem and being able to recognize chain rule, I think that's a good thing for us to be able to do, right? You're not going to be the problem will not say, hey, use chain rule here, use implicit here. It's just going to say find the derivative, and you have to look at the problem and be able to decide what rule is appropriate for this problem. Page 11. Implicit. Can we recognize implicit, and do we recognize the need for other rules? So for instance, if you look at number 7 here, if you're asked to find the derivative, what are some things that you would notice? Yeah, so you know that you have to go through what? But yeah, product rule and yeah, the implicit, right? Implicit differentiation. How many dy dx's are you going to expect to show up? 2. And then this product rule that's going to go on here as well, right? Okay, so let's see if we can do this one here. We're on page 11 here, page 11, number 7. Okay, f prime. X squared times g, no changes. Back to f. Okay, g prime. Good, 3y squared dy dx. Okay, we're not done with the rest of the problem yet, right? We just took care of that x cubed, y cubed. Okay, what does y become? Dy dx. Now, something that I think will be helpful is if you put a 1 here. I want to show you why that is helpful in a second. Put a 1 there. I mean, it's the same thing, but derivative of y is 1 dy dx. But it's for the algebra step later that I think you'll find helpful.
Everybody good so far? Right, equals. Good. Both sides are impacted by the derivative. We don't want to let one side not go through that process, right? Both sides will go through the same process. Okay, so do we get the correct number of dy dx's? Yes. Okay, so now let's collect our dy dx terms. There's 4 terms here, right? Well, these are together. And then I got to move this over to the right side. Just going to. Okay, what can I do here? What's my next step? Okay, factor dy dx. Okay, what's left inside?
3 y squared.
Now, that's correct. That everything you said is good. Now for, I just want to show you, what if I didn't put a 1 here? What do you think students do when there's not a 1 there? Yeah, they put a 0 here and they feel like they're done with the factoring, right? So that 1 is a good placeholder as a reminder that when the dy dx gets factored out, there's still something left there. It doesn't disappear. There's still a 1 there. So I find that to be really helpful. Having that 1 as a reminder that, oh, I gotta have a term there. There's 2 terms. I'm factoring dy dx from 2 terms, so there needs to be 2 terms left over inside the parentheses. Does that make sense? Okay, so now divide that parentheses over, and I have my dy dx. I have my slope formula. So let's say from here, I asked you, find the tangent line equation at order pair 1, 1. What would you do from here? Yep. And then point slope form. Yep, exactly. Yeah. So as messy as this looks, I want you to still keep in mind that, okay, this is just a slope formula. This is just a derivative equation. You give it information, it spits back a number, and that number is the slope, just like how we've been doing f primes in the past. And so if I plug in 1 in for x, I get 1 minus 3 over 3 minus 1, which is negative 2 over 2, which is negative 1. I have my ordered pair, I have my slope, point slope form. I know the problem is not asking for it, but I just wanted to extend it further. If I were to give you order pair, you can always find the slope and answer that equation. Okay, page 19. How do you guys feel about these problems where you have to build out either product, quotient, or chain rule, and then looking from the graph to either pull the slope or the y value? Feel good about that? Okay. Product rule and quotient rule, students don't usually have issues there. Typically, the issues come with chain rule. Right? The chain rule, like on page 20, once you build out the chain rule, you know it's going to take a couple of steps to get to the end, but replace all the x's with a number that you have. Find out what you can find, but make sure you keep everything else in the problem. And there's going to be a second step that's going to require you to find the slope of another point, and then you can get to your answer. So are we good with chain rule?
Question. Tell us which one to technically.
Yeah, exactly. Yeah, I know some of these problems didn't really specify, but it'll be very clear. It'll say, okay, p of x is this, find p prime of 5. Q of x is this, find q prime of. So you should be able to look at the setup of the problem and know instantly whether it's product rule, quotient rule, or chain rule. It shouldn't be any confusion there. You guys good there? You'll see one of those problems. Well, it'll be one graph, but it may be a product rule and a chain rule, or quotient and a chain. One issue that I see with quotient rule that students experience is sometimes students forget about the denominator portion of a quotient rule, so just be aware of that. Or they would do the denominator, but they will forget to square it. So just, I think those are just minor things there, but I just want to point that out. Quotient rule requires the denominator squared. Okay, you'll see a vertical and horizontal tangent problem. How do we feel about those steps? Find the derivative. A lot of times it's going to be involving implicit. And then set the numerator equal to 0 to find your horizontal tangent. Set the denominator of the derivative equal to 0 to find vertical tangent. You guys good with that? Okay. So there's another problem that we didn't do, page 58, which we didn't do in class. The key is attached. So if you want to go through that process and see if you're good with that, you can do that later. And then another big topic is this right here. If I give you a piecewise function, and if I ask you to find a and b, and if I tell you that this function is continuous and differentiable, there's piecewise is continuous differentiable, there's two things you got to do. You got to set the expressions equal to each other, replace every x with whatever x value I give you, and then you have to find the derivative of the two expressions, set them equal to each other, replace the x with whatever number I give you, and then from there, you're just doing systems of equations and trying to solve for a and solve for b. Okay, you guys feel okay with that? Okay, I did this with one of my classes, but I don't know if you guys got to do it. But number 3, do you guys want to try number 3 and see if you haven't done it yet, if that makes sense? But you'll see one of those. And the reason why students struggle with this problem is just, not knowing the setup. So if you know the setup, that's one piece of the puzzle. The other is knowing what to do with the A and B, right? I think a lot of times we get thrown off, right? Well, what is an A? What is a B? Treat A and B like you would if it was just a number, right? However way that you would treat 3, the way you would treat A. However way you would treat 9 is the way you would treat B. So A is not a variable. A is a constant. Okay, check your answer there. Let me know if you have trouble with the derivative. Finding the correct derivative, I'll go through it with you. I think that's, so even if you know the setup, that's where students run into trouble. Not finding the derivative correctly, and then if the derivative is not correct, then you're not setting the equations equal appropriately, and that's going to throw off your answer. If you can find it, if you know how the setup works, and if you know how to find the derivative, it should be pretty straightforward. Thank you so much.
Obviously, you weren't talking about that, but save it 2 steps.
Appreciate it. Thank you.
Open the differential.
Yeah, differentiable.
Yeah, you do the same things you did on the continuous, just the.
The derivatives. Yeah, because, okay, so the reason why we can do this is because if it's continuous, that means these graphs, they must share the same y value of -1. So that means the equations are going to be sharing the same y value. Differentiable is saying that, well, not only do they want to connect, they must share the same slope in order to ensure that there's a smooth transition and it's not the sudden jump, right? It's going to be a smooth curve because there's going to be a transition from one graph to the next. So because we know that they share the same slope, we can set their derivatives equal to each other because we know they must share the same slope at -1. So yeah, I want you to understand the process, but I also want you to understand the reasoning behind it. Why are we doing this? Right? Because we want the graphs to behave a certain way in order for the graph to connect and be smooth in that transition. So if A is 3 and B is 1, that will ensure that the graph will connect nicely between them. Yeah.
Like you do, 4x supposed to do.
4x plus 2. Good. So we found the derivative, right? 2x squared becomes 4x, 2x becomes 2, and what does A become? 0. Because it's a constant, right? If that was an x, then x will go to a 1, but the constant goes to a 0. Right? That's where students sometimes struggle, right? They see that A, they treat it like a variable, but instead you treat it like a constant. Okay. So I feel like I've kind of gone over the major things, but I do want to talk a bit about the very last thing in your packet. If you look on page 39, this is morning review, worksheet 4. I'm going to save to go over this on Friday, but this is what your test basically looks like. You're going to have an extended implicit problem, implicit differentiation problem here, like how you see with 39 here. And then page 40. Piecewise function, find A and B, right? You got the graph with product rule and chain rule. Chain rule and quotient and chain rule again. Quotient rule. And then you have a problem with chain rule again. And then it's something you recognize, an extended particle motion problem. This is what your test will look like. So you can wait to do this with me on Friday, or I feel like it'll be good if you can just practice it beforehand. If you get really comfortable with these 3 pages, you should feel really good about the test. Right? No surprises. If you can do this, I feel like you should be good for the test. All right. So my suggestion is do it multiple times, right? And then if you want to come in Friday with any final questions, with very specific questions, then I can help answer those things as well. I did record this video from last year, so I'll put that video up if you want to watch that video of me going through this before Friday. Okay, so I have another help session this afternoon. Then Friday morning, obviously, Friday morning, so. Okay, so let me know if you have any individual questions. Oh, and by the way, the key is attached
at the back of those pages too, so you can always check your answer when you work through. Okay, see you.
So.